Morning, everybody. It is our pleasure to welcome all our online and in-person participants to this hybrid online live session on predicting potential earthquake using space-based technologies, organized by the Asian Institute of Technology, specifically by the Geoinformatics Center and the AIT extension of AIT. I'm Fazli Karim, Director of AIT Extension. Let me brief you the program. This is a hybrid online session. We will have a 30 minutes presentation by Professor Shunji Murai, the speaker of the session. We will appreciate the online participants to raise their hands or use the chat box to ask any question. Participants attending in person can raise their hands for any question. We will try to compile these questions and the speaker will address this at the end of the session. I will now request Dr. Manzul Hazarika, the Director of GIS, for his welcome remarks and to introduce the speaker, Professor Shunji Murai.
Thank you, Mr. Karim. Good morning, all of the participants in line, online or offline. This is my great pleasure to introduce Professor Shunji Murai, my professor, as well as he was also founder of the center where I'm currently a director. And Professor Murai has been very active in this field of remote sensing and GIS, and many people say that he's the father of remote sensing in Asia. And he has been, throughout his career, he has been always trying to improve the life of the people in the particularly in Asian region. And that is how this predicting a potential earthquake using space technology has come up. And in fact, Professor Murai was always very much passionate about this technology. And see, after his retirement, last 20 years, he has done a lot of research and his theory has been changing. And now today, I think he's going to present his latest theory. And I think we'll get some new ideas about this earthquake prediction. And what he says is that most of these earthquake scientists, they look down to the earthquake for earthquake or related activities. But Professor Murai said you should look up for the precursors. So that's how I think he'll be explaining today. And Professor Murai was also in AIT 2 times, 1992 and 1996. And one of his colleagues that time, 92, Dr. Joseph Arsberger was also his colleague. And he presently director. Yeah, he has been working with many of these big personalities. And he also brings a lot of his colleagues to AIT during his time. And also he has been very much closely associated with the Princess, Her Royal Highness Princess Mahasakri Srindran. And since 92, he has been also organizing some tree planting project with Princess. And I think tomorrow Professor Murai is going to meet Princess, and because he's also going to some tree plantation in the north of Thailand day after tomorrow. And also Professor Murai, apart from his all these activities, he's also he's a very big sportsman. And he said to me that he wanted to become a baseball player when he was a child, but his parents could not afford the gloves of the baseballs. Then when he went to University of Tokyo, he focused on rowing. 4 years, he said, in University of Tokyo, he focused on sports, not in studies. And in that, he represented Japan in World Championship and Olympic in Rome, I think 1960 Rome Olympic. So with this background, I think I hope to have a very interesting presentation from Professor Murai. And at the end of the presentation, as Mr. Karim said, you can ask question, and the floor will be open. Over to Professor Murai.
Can you hear me? Okay, because I'm an old man, so my voice is not clear like a young girl. But maybe I can understand my voice. Okay, Mr. Chairman, Dr. Manzo, ladies and gentlemen, and also many participants in Zoom. I am very happy to be invited to the webinar AIT. So before my presentation, I'd like to make the self-introduction because some of you know me, but most of you don't know me. So I was born, big mistake, 1939, not 2039, this is a mistake. I am now 83 years old, graduated from University of Tokyo, but as the Manzoor said, I didn't go university. I was training the rowing, and then I have never lost the match. Then I was the championship of the Japan. Then I'm lucky to participate into the Roma Olympic in 1960. Then 2 years after World Championship, also I went there because I got the victory in Japan. But don't ask me the result. I lost, of course. So I retired in the year of the 2000. Then I am now the honorary professor. Then my first visit to Thailand in 1974, almost 50 years ago. Then I organized the first Asian conference on remote sensing, so-called ACRS, in 1980 in Bangkok. Then the Princess Shillington graciously inaugurated this first Asian conference on remote sensing. Since then, I did know the princess. I have met several times in the past, and also founded Asian Association on Remote Sensing 1981 in China, Beijing, at the time of the second ACRS. I'm also founder of Re-Green Movement under the support of the Princess Project. This is the reforestation to generate the true tropical forest. So the day after tomorrow, I will join the replantation festival supported by the Princess Project in Swampun, Ratchaburi province. I am also the professor of AIT, firstly 3 years, then 1 year break, 2 years, in total 5 years. So I was working at the AIT. During my stay in Thailand, AIT, I established the Geoinformatics Center. This is a research center. Now, Dr. Manzoor is now director of the GIC. So very successful, I heard. So I'm very happy to know. I was living in the small village along the Chapai River because most of the Japanese faculty used to live in the Sukhumvit, very expensive condominium. But I built small house in the land of my former students from Thailand. Then my land is 1 hectare. Then I bring the 1 wife, 1 dog, and 3 cats from Japan. I will live it together. So this is the very usual experience for us to live in a small village. Every month, in the full moon time, the villager invited us to come to the temple, and I give the tambun, big money. Otherwise, our maid, my professor, is did not pay money or like that. So then I have to pay a lot of money to them. It's okay. I was running. Then this is I was communicated with the villager, very nice people. At that time, my house is only one house which has the air conditioning system. So children would like to come to visit my house. Then they come to get to learning the Japanese language from my wife. Then my wife enjoyed about 8 small children, like a primary school, every week. But actually, they learn only 30 minutes. Then after that, they dance and sing and even cooking. So Thai children is very free. They open the refrigerator, they drink everything, but they go back after they wash their glasses. Very nice education. I enjoy together with children. I was awarded the most exalted order, second class white elephant, 1997. Awarded Boon Indrambaya Medal, 1996. Then I founded the Geoinformatics Center, 1999. Maybe you look at the screen, Her Royal Highness Mahata Kunishiniton graciously inaugurated the opening ceremony, the February 19. Next year we have 25th anniversary. So Dr. Manzoor and me plan to invite Princess Silinton to come to celebrate together with the 25th anniversary. That is why tomorrow I will meet the princess, but I donated big money for the Princess Project to support the very poor people in the border area, like Myanmar or Chiang Mai, like that, for the scholarship for higher education. So this is my support to the Thai people. Then look at Khan here. Predicting the earthquake is the using remote sensing. You see, I am not seismic scientist. I don't know anything about the seismic science. I'm just a remote sensing scientist. But I wonder, the seismic scientists cannot do anything because they have no observation technology. My mission, what is my mission? To save lives from earthquake disaster. So why remote sensing used? Because remote sensing is observation technology. Yeah, any prediction, even the horse race, gamble race, you need the past record, observation data. Then you can predict which horse can get victory. Even stock market the same. Any prediction, even AI use the such kind of observation data. So without observation data, you cannot make any prediction. Please remember this. Remote sensing is the technology to observe the data daily or hourly or even in the secondary. So requirement of the earthquake prediction. So role of various type of precursor. So if I can find the precursor, some special anomaly or phenomena for us should be based on the scientific evidence. Otherwise, I cannot use the precursor for prediction. Yeah? This is we need a lot of the correlation analysis between precursor, candidate of precursor, and the result of the earthquake, that is the occurrence of the earthquake, particularly big earthquake. Because big earthquake, many people die, and then the building also collapsed. So this should be avoided. You look at the picture, the right below. This one boat is landed by the tsunami. And then this boat is just only sit down on the roof of the building. So this is the tsunami disaster. Successful example of the prediction I show you. Then this is the first part. Second part, new theory on what causes earthquake. This is the mystery. Nobody make the answer in the human history. So I try to solve this mystery. So very excellent detective. Maybe they use the footprint, some footprint or fingerprint, some you see some dirty shirts, some other. So then they succeed to get the through the mystery. So new theory. What causes earthquake? Earthquake is a very complicated phenomenon. Nobody can see it because epicenter of the earthquake is normally 30 to 50 kilometers under the ground, very deep. We have no scientific technology to make the direct observation. So, and even shallow case, 10 kilo. Even 10 kilo, we cannot see through. So deeper where is 100 kilo, sometimes the 600 kilometers under the surface. So only we can use indirect phenomena coming up to the ground surface, air, even space. This is the remote sensing technology can help me. So that is my way how to make prediction using remote sensing observation data. So completely different idea. So many people say active fault. Who is making measurement of the movement of active fault? How many millimeter moving per day? Nobody can answer. Nobody make the surveying. And then also plate tectonics theory, yeah. Which plate, which part is sinking or up and was moving? Nobody cannot make the observe. Only the space technology can observe, but only Hawaii and Japan is closing each other 8 centimeters per year. This is the remote sensing technology. But it's only 2 points because we need a 50-meter diameter antenna. So this is too expensive to locate many antenna all over the world. So maybe you understand me. My mission is to save lives from earthquake disaster. Though Japan is an earthquake disaster prone country with huge number of victims in the past. So Japanese government and seismic scientists and society, academic society, officially announced that this is impossible to make prediction. After the Great East Japan earthquake with magnitude 9.1, about more than 20,000 people died because the nation made the booing. What is doing? Seismic scientists and the government. So they cannot answer. Finally, they announced officially, oh, it is, they don't say impossible, but they say it's very hard. It's very difficult to make prediction. Same thing. They say impossible. So that is why I started my prediction way, because I want to save life. I, as a remote sensing scientist, I decided to achieve my mission of earthquake prediction using remote sensing technology to save human lives. I don't rely on the past academic knowledges. I don't read anything about the seismic science. Only I rely on my knowledge about the remote sensing. This is my way of the research. I don't read the book because book cannot give me the answer. You see, many people make studying and research completely different discipline. Research is to find solution which is not given in the past, given in the book. So only your brain can help you. Not book, no any academician, no any textbook. Only rely on my brain. This is my way. Also your way. If you make the true research center. That is why I established the Geoinformatics Center, because AIT education, we are teaching mainly. Because the master paper or PhD paper, lack of budget, they only very little research, only improvement technology. Someone make the 60% accuracy. Okay, I can upgrade 80%. This is the very poor research subject, you see. So that is why I need quite a new technology. I judge only remote sensing technology can provide various type of potential precursor. Very complicated earthquake phenomena. So this is the only candidate precursor. If I can find the good precursor, I can predict. This is a very simple theory. I have continued to challenge precise earthquake prediction in these 20 years. After my retirement from the University of Tokyo, I started my research, new research. So a half century has passed since the first launch of Earth observation satellite, so-called Landsat-1. Now so many satellites, remote sensing data are available freely. So Dr. Goto, my former student, sitting in the seat, he is now working at the Chinese company. His company already launched 4 satellites. Now in future, they launched 52 satellites, radar satellites. My goodness. So this is now, so GPS meteorological satellites such as the GOES and Himawari Japanese case, even Indian meteorological satellite, even the Chinese meteorological satellite, Huiyuan, as well as the ground-based remote sensing sensor, such as infrasound sensor, thermometer even, geomagnetic sensor, aurora device, etc., are also used in my research. At this present, I have discovered almost 10 precursors to decide when, where, and or how large earthquake possibly occur. When we have the business in Japan, many our customers say, oh, I cannot wait more than 1 month. So within 30 days will be the maximum allowance. Where? Maybe this is the provincial level, it will be okay. Yeah. How large? Particularly, we cannot miss the big earthquake. So this is the my requirement. When, where, and how large. So this is the final goal to predict this 3 factors. So I use many kinds of the sensor. Yeah, satellite data, even this is the, oh sorry, this is the American satellites observe the surface of the sun. You know, the black sunspot, this is sunspot. The sun is the, you see how what is generating the huge energy of the sun? Hydrogen gas atomic bomb. That a nuclear fusion occurred, not only one place. Then big bomb exploded. They produce a sun flare, very high, you see, flare, fire flare occur. Yeah. So this is my way of the firstly scientific observation. Sorry, some part the connection. Scientific observation data, daily or hourly remote sensing data. Then I find the candidate precursor of earthquake occurrence. Then correlation analysis between candidates precursor and the past earthquake record. This is very important research. Then, if good accuracy, the candidate can be precursor. Very simple. If not good accuracy, try another candidate. Then we make this kind of cycle. Then I found and discovered many precursors. I will show you several of them. Sorry, before that, requirement, I already mentioned. When? Within a month. Where? Within a certain local area. How large? More than the magnitude 6 or 7. Large earthquake, more focused. My company, Japan Earthquake Science Exploration Agency, just abbreviation is the JCR, defines so-called pinpoint earthquake prediction. When, where, and how large to fulfill the above requirements. We have about, in total, about 100,000 subscribers. Not many, but still better than nobody. So our pinpoint company's pinpoint prediction has been distributed to the subscribers in the form of weekly mega earthquake magazine or web service since January 2022. Officially, I initiated in 2013, but the pinpoint started from last year. The main role of pinpoint prediction is to provide preparedness in advance to incoming large earthquake to save human life, as well as to protect the economic activities. This is the purpose. So look at this. I don't explain one by one. So epicenter is very deep underground. This is the epicenter, earthquake occur. Then under the ground, some infrasound. Infrasound means human eye cannot hear. Elephant can hear better than human being. But Kauai National Park, Kauai Park, tsunami time, the elephant escaped before human being because the elephant can listen to some sound of the tsunami. I think so. So the infrasound, this is the military technology. China developed this infrasound sensor because if the North Korea made the atomic bomb test, explosion test under the ground, we can detect the infrasound sensor. United States already have the network of infrasound sensor network. Then can they detect any country, even Russia, China, even the North Korea made the atomic bomb test, we can detect. And GPS, of course, XYZ coordinates can be monitored. In Japan, 1,300 GPS stations distributed all over Japan. And then even the geomagnetism and aurora. Aurora is the beautiful sky in the North Pole, the South Pole. But ignore aurora generated. This is the signal of the big earthquake. Yeah, so nobody knows about that. I found it. Then even the sky or even space, ionosphere, also we have some anomaly in planetary events like a sun and moon and Mars, or sometimes Mercury, or even the Venus, like that planet also correlate with the earthquake. This is my finding. So I don't explain one by one. Daily change of XYZ, infrasound center, cloud pattern from the meteorological satellite image, even air temperature. Normally, air temperature decrease from the midnight to the 4 o'clock in the morning. But some special day, the temperature raise up 2-3 degrees. This is the one of the precursors. So nobody believed, but you see, we found it. Even air temperature like that. Geomagnetism and auroral electrojet, we have the very internet site. We can check every day, planetary event also, like that. So I will show you XYZ change, infrasound, when, where, and how that. Some precursor is the very good in the when, but where is unpredictable, predictable. But someone is good. So this signal is the I rely on mainly cloud anomaly of satellite image. A special cloud pattern, linear pattern, stay 5 to 10 hours before earthquake. Every day I check the meteorological satellite. Every day. So I need about 30 minutes to check everything. Not only Japan, but also Taiwan, Philippines, India, Nepal, and Indonesia, Papua New Guinea, and Fiji Island, like that. So Asian region mainly. Magnetic fields or magnetic flux and auroral electrojet is also very important. And planetary event, including a new moon or full moon, even. I will explain under the second part of the new theory. Nobody believe, even I don't believe first. This is just only, you see, it's very strange, the earthquake. So look at this. Cloud anomaly, this kind of linear, different pattern of the ordinary cloud. This is staying 5 hours or 10 hours. So cloud anomaly appeared the end of the March this year. What happened? Then you see the earthquake occurred like this here, a little far, but almost this area. This is allowable because under the ground, nobody knows how the epicenter is very deep, about 50 kilometers under the ground, even shallow case 10 kilo. Their geological structure come the oblique way or not only straight up. So that is why the cloud generate different place, but nearby. Yeah, that is why this is allowable, the 7.0. I predicted. I sent the Dr. Manzoor about this one before that. So if you look at this one, this is my way This is the American deep space satellite. Discover satellite give us the magnetic flux or field anomaly. Huge. I set up this one disk area. This is the more special case. So this is the high. And also the aurora electrojet. This is the strength of the aurora. So this is the risk area. It's almost a very high risk region. So this is the occurred at the 23rd of March. It's just before. So then also we analyzed the sinking or rising the land using the GPS data. The blue area is sinking. This area is very critical. We have the earthquake nearby here because the top of the peninsula is rising, but the other part is sinking. So like this. So this kind of the stress is very huge, then earthquake occur. And in this area, the Tohoku area, a tsunami is also generated from the epicenter more far, but we have a very often here because the west part of the Tohoku area, East Japan, Northeast Japan is sinking, but here the rising because at the Japanese Great East Japan earthquake, this is sink about 1.1 meter after the earthquake. This is now getting recovered, still rising, but not yet recovered 100%. So this is a GPS station. We have a 1,300 stations all over Japan. So we can make such kind of map using the GIS technology. But this technology, the accuracy of when is about 2-3 months. So this is my start point. But this is useful, but our user can say, oh, Professor, I cannot wait 2-3 months. Please tell us the 1 month accuracy prediction. This is the user's voice. So this is the China-made infrasound sensor. I bought the sensor in China and bring back. Then the China airport inspection, they check, but I got some special letter of the certificates in Chinese letter. I show them, I succeeded to pass them. So this is the, you see, Fukushima disaster, offshore earthquake, it's more than the magnitude 7. We have such kind of the anomaly. Every day we are observing this one. But if we can locate the epicenter, we need several different point sensor. So I have only 2 sensors, so we cannot decide the where. But anyhow, if we have such kind of the precursor, then about 2 weeks after, big earthquake may occur. So this is another Fukushima offshore earthquake, 7.4. We have such kind of the shaken area, cracked area here, and then the epicenter is here. So this is confidential. This is the also special cloud pattern. 5 days before, then earthquake occurred 16th. So my goodness, my company provide the information to the user every Tuesday. This is the 16th March. 4 o'clock in the afternoon, we distributed. Then the earthquake occurred at midnight. My goodness, That's only safe. So many people were shocked. Okay, immediately after our distribution of the alert, then earthquake occurred. So many of the magazine came to me, and also they made some articles. So look back to the Sumatra earthquake. This is the biggest earthquake in this century. Tsunami 34 meter. Maybe you know many Thai people also 5,300. Particularly Kauai area is the not Kauai, south part of Thailand, beach area, a tsunami. I went there, and in India also 12,000, Sri Lanka 35,000, but Indonesia of course big. So, what is the precursor of that one? So, if you look back, the magnetic field quite big, the anomaly about 2 weeks before. And this is the magnetic storm. And many precursors there. So I did not make the prediction in this way at that time. This is my validation research, high risk. So magnetic field very high. Solar wind density is also very high. Electron is very high. Geomagnetism, magnetic storm there. So why not the earthquake occur according to my prediction methodology? Okay, same thing, Sumatra. I checked the aurora electrojet. So this is almost high risk zone. So then maybe some of you don't believe me. You see, 2004, December 26th earthquake occurred. But 12, about 2 weeks before new moon, but 12:10, Sun, Mercury, and Earth make the straight alignment. This is called the planetary series. And then the 4 days after, Earth, Mercury, and Venus make the straight alignment. Looking from the Earth, Mercury and Venus cross and touch each other. So many, you see, telescope is taking the picture of the Mercury and the Venus to get married. So this is happening. Such kind of one, I will explain in the second part. Why I also use such kind of information. I use. Otherwise, you don't understand. Then I make the comparison between the Sumatra earthquake and Great East Japan earthquake. Both are magnitude 9.1, maximum magnitude in the this century. Magnetic flux is also we have anomaly. Solar wind density is there also. Electron there. Geomagnetism also. Geomagnetic storm there. Like that. So this is what we are distributing to the user from my company. So some of them precursors appeared, but no earthquake happened, incorrect. And someone is correct, some are almost correct, a little bit the epicenter, a little bit the outside, but maybe allowable, almost correct. So about 75 to 80% accuracy, correctness is obtained. So now the user is allow us such kind of missing. So pinpoint prediction to forecast when, where, and how large has been achieved without avoiding all possible relevant precursors observed with the remote data. I'm always trying to check the all possible, all difficulties. Otherwise, you see, because we don't have any reference data, any textbook. So that is why I rely on only remote data. The correctness of the pinpoint earthquake prediction served as the business to about 40,000 subscribers since January 2022. Prediction accuracy is about 75 to 80%, as I mentioned to you. As a result of my 20-year research activities on earthquake prediction, I propose a new theory. The solar dynamic anomalies cause large earthquakes. This is the second part. I wish to serve myself for particularly Asian people to rescue human lives from earthquake disaster by providing accurate pinpoint prediction. So I started to make the prediction from the April the 1st. Every day I am checking the precursor. So now I'm very happy to present you my new theory. So justification of my theory, the mechanism, what causes earthquake is not yet verified scientifically. Nobody has done before. Considering the phenomena of earthquake are so complicated, I have reached the assumption that the solar dynamics anomaly accompanied with the nuclear fusion of hydrogen atom may induce earthquake. The solar wind is blowing to the earth, not airflow. The geomagnetic flux flow with very high velocity, 300 to 700 kilometers per second. It's like atomic bomb. Yeah, when the velocity exceeds 600 kilometers per second, with very active sun flare, the Earth will be moved by swirl phenomena, together with the geomagnetic storm, as well as the solar storm, so-called solar storm. Look at the sun and Earth. Earth is very small. The solar wind blowing, then this is going up and down. But in case the moon is coming inside, so this wind is the swirl and then shaking the earth. And even the Mercury or Venus also can come into the alignment. Even the outside also make a straight line. So this is very big disturbance of the solar wind. So this is shaking the earth. Yeah. As a result of such anomalies, high temperature and highly pressured liquid mantle or magma of deep underground is driven to erupt upwards. If erupted, this is volcanic eruption. The volcanic eruption and earthquake is the same root, same reason. In case of the earthquake, I will give you the another next slide. We call so-called degassing. Gassing upward is called degassing. This already discovered about 30 years ago by the Russian scientist, not seismic person. Degassing effect. Sudden subsidence happens maybe because the hot mantle or magma come up and then stop it and they start to cool. So they come down immediately. Then this is making the earthquake. This is my assumption. I assume this could induce earthquake. In case when specific planetary events are synchronized, huge earthquake may occur. I will show you another one. Look at the Earth. You know, everybody knows. Earth rotate one round about 40,000 kilometers around 24 hours. This is making the 472 meter per second speed. Very high rotation. Then revolution around the sun, 365 days, one round. This is more higher. Speed is 30 kilometers per second. Suppose that if you put the water in the bucket and then you rotate like that, what happened? The water inside. Water want to jump out outside of bucket. So high temperature leaky magma, mantle or magma always force the erupt to the Earth's surface by centrifugal power. Yeah, you understand? This is not hard rock. Inside the Earth is melting more than the 3,000 degree or even 6,000 degree, 3,000 normally, liquid. So they want to come up always because there's some weak area of the fault or some, you see, geologically weak area, they try to come up always. So volcanic eruption is erupted, but earthquakes get degassing, gases come out. That is why I monitor the cloud from the meteorological satellite. This is the precursor, real precursor. So this is very important, the meteorological satellite monitoring. So that is why my theory, nobody believe, not many people believe me, but I believe myself. So in conclusion, large earthquakes are caused by the solar dynamic anomaly. Definition of the, I already made the research on the giant earthquake, larger than magnitude 7.8. This year, Turkey had the 7.8 magnitude earthquake occurred. More than 50,000 people died. And a lot of the victims and how this corruption. To find the precursor appeared in advance to gigantic earthquake. This is important. So I made the validation. Yeah, 30 days in advance. We had some very clear anomaly or precursor detected or not. So my conclusion is about 90% probability accuracy is there. Example like this. Aurora electrochart. Maybe I will show you. This is Turkish case. Of course, I did not make the prediction before, but I made the validate the Turkish one. Anomaly of magnetic field appeared on the about 33 days before. A little longer, but also allowable, almost 30 days. This is high risk area. And geomagnetic storm there. And aurora electrochart also risk line. You see, maybe you understand. This is 21 days before. Either magnetic flux or aurora electrojet occur, big earthquake will happen. So this one is 33 days, a little bit longer, but 21 days is allowable. So we rely on two precursors. They are two precursors complementary each other, help each other. So this is my finding. So the reason why I use such kind of the magnetic field, geomagnetic storm, and aurora electrojet. Reason one, the Earth is exposed by super high speed and high energy solar wind that is generated with nuclear fusion of hydrogen atom. So reason two, the Earth, particularly middle latitude and zone, and is protected by earthquake magnetic field. But the polar area is more severely shaken by huge energy of solar wind. That is why aurora appear. So that is why aurora is more sensitive rather than the other area. That is why the reason I use the aurora electrojet. Reason 3 and 4, in case of huge nuclear fusion, geomagnetic storm occur. Reason 4, I consider gigantic earthquake, big earthquake, will be caused by anomaly of solar wind that destabilize the Earth's weak zone, such as the border of place or active fault. My decision on candidate or precursor, two indices of satellite observed magnetic field or magnetic flux and aurora electrojet, AE, which are complemented each other to make higher accuracy. If you wish to monitor by yourself, I got the Japanese written, but this is the site of the internet. You can download anytime, free of charge. So I don't hide. So influence of the solar wind upon the Earth is very huge. As I already explained, but look at this one, like that. So solar wind is more severe around the north and south pole area of the Earth. In case of magnetic storm, aurora will be generated. Magnetosphere protect the middle latitude or some middle latitude zone of the Earth from cosmetic rays. So this is also aurora electrojet of the Turkish way. So look at this solar dynamic with nuclear fusion. So this is the remote sensing image of the American satellite. Yeah, solar dynamic observatory, SDO satellite. So this is very important. And sun is also rotating 27 days per month, one round. And the number of the sunspots also changing every day. Big number is about more than 100 sunspots. Few are the only 20, 30, 40 sunspots. So such kind of the solar dynamic observatory satellite is very important for the human being. So American people don't know I'm using this one for the earthquake prediction. But I'm very happy to use this kind of image. Every day I check such kind of image. Every day the sunspot, sun surface is changing. I cannot see my eye, it's too shiny, but we can see. You look at this. Earth is one of the planet, solar planet system. So very small planet. Very luckily, we can survive. So Earth cannot survive without another planet. We help each other, but also they are also making troublemaker for us by inducing the earthquake. Yeah, maybe okay, maybe it's okay. So that is the Earth. I think you understand my new theory. I don't believe my new theory is spread over in the world. Maybe very few person knows about my new theory. Please survive yourself. Please extend new theory to other people to protect and save human lives. This is my wish. I don't want to become very famous professor anymore. I already done many things, but I like to help people, particularly Asian people, disaster prone country, particularly earthquake country, like India, Nepal, and Indonesia, and Taiwan, and China, of course, Japan, and Papua New Guinea, and Fiji, even Tonga, small island. So, thank you very much for your attention.
Thank you, Professor Shinji Murai. In fact, when Dr. Manzul was telling, I was also a student of Professor Murai, and not only me, my wife is also a student of Professor Murai. It's a very good presentation, and I would request the audience, whether it is in person or online, please put your questions over here, and we will compile and we will try. We will compile, and then Professor Murai will address those. So please raise your hands if you are in person, those who are in person, and those who are online can put their questions in the chat box or Q&A.
Yes, I found the one person. Yes.
Please.
Hello. Thank you, Professor. It's very interesting.
Yeah, now I can hear.
Right. Okay. So it's two questions. One of
No, one by one.
Ah.
I cannot remember two.
right. Okay.
Okay.
Does Japan have a network of like magnetometers to measure the incoming say like pulsation from the storms to correlate with
Good question and a suggestion. I'm now contacting the Dr. Manzur because the GNC had the network in Asian region. So I try to provide my prediction information alert system to Dr. Manzur. He also maybe invited some user from Turkey, Indonesia, Nepal, some other country. And then at the beginning, maybe we provide free of charge. After some several months, I don't know, maybe we charge minimum money to support us. Yeah, and this is the our planning.
yeah, no, because I measured the incoming pulsation from solar storm in the northern of Scotland. I think it's one of the highest like on land in the polar circle. And then we do get like some weak signals, but it's not big. So I was just curious of the scale of these like incoming pulsation that could induce the earthquake.
Yeah, you see, it's not very easy to
Yeah.
answer very simply. It's every time is case by case because any earthquake is different type. Because even shaking like this, and also like this, so complicated. Even the epicenter depth is also changing. So it's not easy to say only one way. Sorry. So this is the it's variable to make my research. Very, very simple phenomena. Anybody can answer, make answer. So that is the, you see, good question. But if you like, you can join me together with the research.
Am I allowed another question? Like quickly.
Yes,
So
which
in
one?
this,
Because we have many other people, yeah.
okay, these combination of precursor
Yes,
weight them because say with the degassing,
yeah.
if it's like in the ring of fire, because the oceanic plate that goes in is more saturated. So
Okay.
that means there'll be a lot more degassing, say somewhere inland, like around the Alps, for example.
Okay, today I give you the very special answer. No, I focused on the cloud pattern of meteorological satellite.
Right, right.
This is number one. Number two and three, complementary, as I mentioned to you, geomagnetic flux anomaly and aurora electron jet. This is very reliable. But where is only rely on the cloud. So this is not enough. So then I will now checking and also I start the research about the anomaly of temperature increase in the midnight. But observatory station in Japan is very many, but Asian country, you don't have a many station of the climate change. So our meteorological agency provide a database. And so that is why this cannot be provided to the Asia, but only Japan. But the other one, as I show you, I can give you the website, so you can check it every day. Everybody can do it.
Right. Thank you.
Okay.
Sorry, one thing is, can you introduce yourself, please, before you ask the question? So yeah.
I'm Kitipon Bunma from GIC.
Oh, you're from GIC.
Yeah.
Okay. You should know. Okay. I will help you. Yeah.
But today he will join us to this stuff.
Okay.
So
Okay.
you can talk to him today.
Yeah.
Okay, so there are some online question. One is from Myanmar, in Myo Min. He said that I'd like to ask, concerned with using infrasound data, did you put this infrasound sensor at the earthquake predicted area?
Myanmar, yeah.
Myanmar. I mean, his question is, have you tested this infrasound in some earthquake area or for prediction? Have you done that or not? That's the question.
Yeah, it's a good question. Of course, Myanmar is one of the disaster-prone country of earthquake. Before we had the Myanmar earthquake, so we found a special cloud pattern appeared in Myanmar. But unfortunately, the earthquake occurred. It's not very big, magnitude 5.5 like that. So not very big. So not damage so far. So in case of the Myanmar, I got some contact point before the Myanmar person. At that time, I used the GPS station. So Myanmar, it's very difficult to get the GPS data. Now the data is open to anybody. In the Myanmar, would like to a member of the subnetwork under the GIC, we are most welcome to provide information to them.
So this infrasound data, have you been able to use for prediction of earthquake or not?
But
Infrasound data, infrasound.
infrasound sensor?
Yeah, sensor.
No. It's difficult to locate many infrasound sensor. So China, you have some network, yeah? I know the Beijing University of Technology, they use the infrasound sensor. They have, but not many points. They collaborate with Taiwan people. So they also predicted not really the location, but they predicted the Kobe earthquake before.
Mhm.
They got the anomaly in Beijing.
So you mean because there are not many sensors, is it difficult to point but where it will be?
Yeah.
But you
Because
get
the-
some signal if some,
Yeah. Because the
sensor is there.
developed country, very difficult to set up the new sensor.
Okay.
Better to use the free charge website.
Okay.
What is it called? Because the meteorological satellite image, I don't know the other area. I paid about some money to establish the database of the Asian region, Japanese meteorological satellite image data. Because otherwise, Japanese government database is disappear every 1.5 days. So we cannot keep the data. So we cannot get back the data. So that is why I established the database,
Okay.
some money.
Right.
So I am now recommending to make the database of the using Indian meteorological satellite image.
Mm.
Then this can cover more area, Azerbaijan,
Mm.
Turkey area. So
Yeah.
this is now I'm negotiating. So then I can cover all of Asia.
Right.
The Myanmar case, of course, they like to make a prediction by themselves,
Mm.
but it's too much tough.
Yeah, I remember. I think Dr. Ian also
Yeah.
I think 2 months ago you predicted a big earthquake in Myanmar.
Yeah,
But what happened is we look at it. There are 3 earthquake around 4.5 in
Yeah.
the
yeah. That's a
in
small one.
successive days. So I think then if 2-3 earthquakes occur frequently, then you cannot get the big earthquake. I think that is what happened in Myanmar. And I think you're also predicting another big earthquake in Taiwan in next 3 weeks. That's I have got from you. So we have to see next 3 to 4 weeks is
Yeah.
big earthquake happen in
Yeah, I am
Taiwan.
predicting in Taiwan. Yeah.
Yeah. So that's why I'm also looking into it. Let's see. Okay. There's another question. Pranav Sethi. What is the cloud anomaly and how is it different from regular cloud formation?
This is a top secret. I
Top
cannot.
secret. Okay.
I cannot earn money because I teach.
Right.
Sorry, I cannot teach
Okay.
because I have a big mistake because my former students collaborated with me with such kind of research, and then I tried to make this submit the patent in Japan. Then I wanted to make a draft of the patent application. Then the student stole my patent idea. So he already applied the patent,
Oh.
patent. Then I charged the court. Then we won, but I paid some money to this terrible former student. Normally, my former student is a very good guy, but this is a very special case. I was so much disappointed because if I teach, they start to make the business. You see?
Oh, I see.
So this is happening in the past. That is why I say this is a top secret. I'm sorry, I cannot teach.
Okay. Thank you. Any questions from the audience here? Yeah. Last one, same person. Same person.
Yeah, sit down, sit down.
Oh, sit down, okay.
It's okay.
Sit also- Yeah, identify yourself.
Oh, yeah. Okay. So thank you for the lecture, Professor Murai. So my name is April. I'm from Geoinformatics Centers also, GIC. I have a really basic questions actually, because I don't really have much experience in earthquake. But I wonder when you are using GPS XYZ analysis,
Yeah,
it's usually have different kind of precisions, right? And then how can you sure that, for example, GPS in the phone, it has like 5 meters accuracy, but with your pressure shares, like how sure that you think that this is the anomalies? And okay, maybe one person.
Okay, that's very good question. Okay, GPS. Now the current GPS are the millimeter accuracy originally. And then you see, but Japanese government provide us the GPS data. And also we established our own GPS station. But anyhow, it's not many. So anyhow, we can use the even the 10-second interval GPS data, but it's too much. Normally, we use the hourly data is enough. Then we have a different type of the analysis. The most important, the tendency of rising or sinking, and also direction of moving. I also got the patent for the mini plate theory because after the big earthquake, Japan is composed of the 4 different plates, but big plate is very huge. But even small part of Japan is divided into mini plate, so they push on each other or even apart in each other. So this is the checking. So from a certain period to another certain period, how many centimeters go up and sinking, and then the sudden change also. So such kind of analysis done, and then important thing is to using the GIS technology, we make map. I showed before in the slide, color slide. So this is actually point data. So it's like a color painted sinking anomaly. And so every week we are checking each other. So this is down. And also we apply the AI technology, artificial intelligence. And then the dangerous order, number 1, number 2, number 3. So this is also down because how to use the AI. So this is also now I got the patent already, so I teach you. How about the earthquake? This is the meaning. Disturbance of the GIS data is the meaning of the earthquake, but sometimes not moving, quiet, very important information. So I use the how quiet the earth area is just the opposite side of the anomaly. So I use such kind of AI technology. Then we announced the number 1, number 2, number 3 before we distribute the alert information to user. This is not open to the user, but inside the company, we are checking every week, every day, one person checking such kind of changing using the GPS data. So GIS data and GIS technology is very important. Okay.
Yeah, I think it really answers my
then,
question.
But
Good.
just what I mean, sorry. I want one more important tendency. I discover what kind of the GPS data anomaly before the Great East Japan earthquake accompanied with the tsunami. Then I found this area, Tohoku area, northeast area, is sinking and sinking and sinking. So sinking is more dangerous tendency. So rising is also dangerous, but not much. But the gap between sinking and rising is more important. And sinking is more dangerous. So this is our analysis. So we are always checking which part of Japan is sinking. How large? What is the time series? So 2 years back, well, this year or even 10 years, 5 years back, 2 years back, like that. Tendency analysis is also very important. We need a lot of time to make the analysis of the such kind of one. This is also confirm the accuracy of the earthquake prediction. I don't rely on only cloud, but also supporting such kind of the basic technology. So then our accuracy become very reliable. Understand? So because if I teach just on the cloud, he or she only use the cloud anomaly. They never use the GPS data, other additional data. So this is the, you see, sometimes it's a fake information. So this is very careful. It's not easy. So not very easy. It's a very complicated science. You understand me? Huh? Okay, thank you for your question. Okay, maybe.
Yeah. Thank you. Yeah.
Maybe time is coming.
Yeah. We are
Okay,
coming to the close of it. And just to inform everyone that the video will be posted in the Facebook and YouTube of AIT Extension's website. And any individual can contact AIT Extension for the recorded video or the presentation. So I would like to thank Professor Murai for this wonderful presentation. And I would like my colleague, Dr. Manzul Hazarika, to close this and with a vote of thanks. Thank you.
Thank you, Mr. Karim. I think this is some of this collaboration with AIT Extension to organize this kind of webinar. And particularly this webinar is, I see a lot of interest, and I think it will be kind of eye-opening for a lot of our AIT community as well as outside. And I like to thank Professor Murai for agreeing to deliver this lecture, and also future collaboration in ASEAN region for predicting earthquake and save life. That is what is your mission is, and we'll be very happy to collaborate with you. Maybe I will make a team in GIC which will be closely working with you and predict this earthquake and carry forward in future. Secondly, also, I'd like to thank you all the audience here for your interest and coming here to listen this lecture. Also, those who are online, I'd like to thank. And finally, our partner and organizer of this AIT Extension, Executive Director, Mr. Karim, and other colleagues for make this happen. And I think we'll also in future, we will continue to collaborate on this kind of lectures in future. And as Mr. Karim said, that maybe if you have any further questions, and maybe you can send us an email, then we can forward this email to Professor Murai so that he can answer your question. Because we are running out of time, we have to go to Bangkok now with Professor Murai.
Please provide me the question in the
Yes, I'll do that.
So I'll try to answer later
Right,
on.
right. Okay, thank you very much. We close the session here, and have a good day. Thank you.